Hello, today I'm going to be doing a video on circuits. So series, parallel circuits, kind of the conceptual stuff, not the numerical pieces, but more the conceptual stuff. And I'm sorry, I forgot to wear a dark shirt, so I'm going to try to stay away from the writing so you can still see me and the writing. So with circuits, the two main types of circuits we deal with, actually I'm going to start with the basic. Our standard circuit is just a one battery, one bulb circuit. And we call that our standard circuit. That's the standard brightness for a bulb. And then we've got the other types. We've got a series circuit. And then we've got parallel circuits, where we've got the two bulbs in parallel. So what we know about these circuits in series, we have to have the same current everywhere, because the current, if there's a certain number of electrons flowing here, it's the same one here, here, here. So the current has to be the same in a series circuit, because there's nowhere else it can go. And the total resistance, as you add bulbs in series, the total resistance increases. Now in parallel, we do have other places for electrons to go. So electrons are coming here, and whoop, some go here, some go here. But what is the same in parallel is the voltage. So the voltage stays the same across the branches. So this voltage here and this voltage are all the same. And the total resistance in parallel goes down. So as you add bulbs in parallel, the total resistance goes down. So I'm just going to do a couple of real quick small circuits, talk my way through them, and show you how to think about different types of series parallel combination circuits. So let's do, let's see, I've got a couple ideas. We'll do this, and then this, and then that, and then that. Okay, so here is a series circuit. There's only one path. So this is all in series, and when we're dealing with series circuits, if all the bulbs are equivalent, which unless I tell you otherwise, you can assume the bulbs are all the same bulb, same resistance, then what we do to figure out the brightness of the bulbs is just kind of count up number of bulbs to number of batteries. The more batteries we have, the brighter the brightness is going to be. The more bulbs we have, the dimmer the bulbs are going to be. So in this case, there are 3 batteries and 3 bulbs. So you might say it's a 3-to-3 ratio. That's the same as a 1-to-1 ratio, but it's not, because we have to look at the orientation of the batteries. This battery is trying to push charges in this direction. So this battery is trying to make current go that way. This battery is making current go that way. So these two are opposing each other. This one is making charge want to go that way. So when we have opposing batteries, and it doesn't matter which two we talk about as opposing. You could say these two are working against each other, or these two are working against each other. What effectively happens is 2 of those batteries cancel each other out. Now, the weird thing is that charge still flows in the circuit. It doesn't all just stop. It's just that these 2 batteries are effectively gone. So what we have in this circuit is 1 battery to 3 bulbs. So each of these is a 1-to-3 ratio. And if standard is a 1-to-1 ratio, this is going to be very dim, 3 bulbs. So 3 bulbs with 1 battery, those are all going to be lit equally, because in series with equal resistance, the bulbs all light up equally, and because there's 3 of them, it's going to be very dim. There's not a lot of current going through this one. So that's one example of a series circuit. We can do a couple of parallels. The parallels tend to be harder for people, so I'm going to do a couple examples of the parallel circuits. Let's do this one. Oh boy, this is going to be a hard one. This has a ton of batteries and a ton of bulbs. What do we have going on here? All right. So this is a parallel circuit because it has multiple branches or loops. So we have junctions where we have options about where charge can go. When we're dealing with circuits, the thing to remember is that batteries control the circuit. Batteries are what cause charge to flow. So the batteries are the thing that control what's happening. So you always want to focus on the batteries in a circuit. And the nice thing about parallel is that you can ignore certain branches. So if I want to know how these bulbs are, what the brightness of these bulbs are going to be, I can kind of block off certain branches. And I want to block off the branches that have the least effect on the one I'm looking at. It's hard to say that. So these two bulbs are in series with each other. So they're in series because whatever flows through here is going to flow through here. They're in parallel with this one. So this one's separate. These two are going to have the same brightness. This one might have something different. So let's focus on these two to start. And the cool thing with parallel is you can block off certain paths. Now I've got two batteries here and one battery with a bulb here. These are going to have a stronger effect on the circuit. So I'm going to pretend that this branch right here is gone. So I'm just going to look at it as a big circuit without this middle branch. So if I look at it as that whole, I have two batteries and three bulbs. Two bulbs. Two bulbs, three batteries. But these batteries are going to oppose each other. So again, ignoring this, I've got these two bulbs and effectively one battery. So this is one battery to two bulbs, one battery to two bulbs. So those are dim. Those are both going to be dim. All right, so now let's figure out what's going to happen here. And we've got this direct connection to these two batteries. So I'm going to ignore this whole half of the circuit and just focus on this loop right here. So here we've got three batteries and one bulb. And in this case, all the batteries are helping each other because this battery is pushing charge that way. These two batteries are both pushing charge this way. They're all trying to make charges flow in this loop. So ignoring all of this, this is three batteries to one bulb. This is going to be very bright. Very bright because we got three batteries working on that one. So those are two examples. Here's a series, here's a parallel. I'll give you a couple more examples, figure out how to determine the brightness of the bulbs, and hopefully that will help people figure out the kind of difficult, it's been tricky for some, objectives 27 and 28, the circuit stuff. And this takes forever to erase. Okay, let's go for another one. Here's another one that is a parallel circuit. So parallel with that bulb, and then we've got parallel with a battery and a bulb. Okay, so what do we have here? Parallel because we have multiple branches. And again, with parallel, the cool thing is you can ignore what's happening in other branches. So if I want to know what's happening in this bulb, for this bulb right here, I'm just going to say, let's ignore that. It has a direct connection to this battery. So this bulb says, oh, I can get charged up from this battery. I can run off of this battery. I don't care what else is happening. So this one, 1 to 1. This is going to be standard brightness. Now with this one, you might say, okay, which one am I going to block off? I could block off this, I could block off this. But remember, batteries control the circuit. So it doesn't, this bulb doesn't care about this bulb here. It cares about the batteries in the circuit. So I'm going to block off this center point and go, well, what's happening here? I have two batteries and one bulb. The two batteries are opposing each other. They're both trying to oppose each other. So this is like 0 batteries to one bulb. 0 batteries. This thing's out. So there's another parallel circuit. And again, if you're not sure which branch to block off, then deal with the one that's got the most batteries, or batteries alone in the circuit. Batteries in a branch or a loop of the circuit. Let's get that one done. We'll do one more, I think, maybe 2. If I can get this board cleaned. All right, how about another one? Ooh, let's do 2. I got 2 more interesting ones. So here we've got what starts out as a series circuit, but then I'm going to toss on a battery there. Okay, so this is series. It looks like it's series, but we have a junction right here, so it's not purely series. These two bulbs are in series. It's one right after the other. Whatever goes through this bulb is going to go through this bulb. But this is not in series technically with these two because there's a junction here. Charge can move, can change how, so the amount of current that's coming through here is not necessarily the same as the current going through here. So let's figure this out again. All right, we have these two and then this one. Well, this one, I'm going to look at that and say, hey, this has its own path to the battery. So this one right here, that's 1-to-1. This is going to be lit standard. Because this one says, I am just going to run off of this battery. No problems. Now with this one, all right, we've got a battery here, and then we've got this junction and this junction. They're parallel. We can block off one of those parallel branches. And then again, keep the one with the battery. So I'm going to block off the bulb. So if I redraw this one a little more cleanly, it would look like this. If I just ignore that other branch, it kind of looks like that. And this battery is pushing charge that way. This battery is pushing charge the other way. So these two batteries are opposing each other, which means that there's no voltage across these. There's no current going through these. Those are both out. Because, yeah, it doesn't matter what's happening here. This battery is trying to push that way. This one's this way. They're done. Let's do one more. One last one. Another parallel series combination. And this one, we're going to think about it just a little bit differently, which is why it's a good one for me to give you for practice. And then we squeak it in there. Here, we only have one battery. And again, it's a series parallel combination because these two are in series with each other. But this is a parallel combination. And this bulb is in series with this parallel combination. So it's kind of a series parallel series circuit. So how do we figure out the brightness? There's only one battery, all right? So charge is going to come out, and all of the charge, all of the current, is going to go through this. So this gets all of the current from the battery. What's going to happen to that current when it hits here? Some of it's going to go here, some of it's going to go here. What amount is going to go onto each of these two branches? This is a single bulb. This is two bulbs in series. So this branch here, this left-hand path, has twice as much resistance as this does. So this is twice the resistance. This is just a single bulb resistance. So this is twice as hard for charge to flow through. If this is twice as hard for charge to flow through, we're only going to have half as much charge going there. So this branch is 2R across the whole thing. This is 1R. That's a 1. Which means that we're going to have half the current coming down this way as we do this way. And I'm going to be careful. This is all of the current from the battery, but not all of that's going to go here. This is going to split up into those two. So in terms of brightness, well, I've got a certain amount of current. I've got half it going here, and these two together have to add up to that. So if you want to do it with numbers, just make up some numbers. You can do that. So if this is like 10, whatever, 10 milliamps, whatever, this would be 5, half that amount of current, which means this would be 15 coming through here. So those would, if we talk about in terms of amps. Now we can figure out what the brightness is. So the brightest bulb is the one with the most current going through it, since we're assuming equal resistance. So this is the brightest. This will be next brightest. And then these two are going to be very dim. I don't know exactly how they would compare against standard. Well, they're all dimmer than standard. So I wouldn't call this standard. I might call this dim. Let me get a different color here. I might call this one dim. This is more dim. because it's going to be dimmer than that, and these two both are very dim. They're very, very dim. They're barely lit at all. And so in this case, brightest, next brightest, equally bright, and the lowest brightness. So those are some examples of circuits and trying to figure out the brightness of the bulbs in various circuits. So that's the kind of stuff that you should be able to figure out for the objectives 27 and 28. And I hope that makes sense. I hope that is helping you figure it out. All right? Thanks for watching. Good job.